Mhm. Hi and welcome. My name is Tor, and I'm gonna have a presentation about our Noroff course called program called Python for Finance. So Python for Finance is a program aimed at people from the finance industry. So whether you have worked in banking, insurance, or financial markets, this is a course for you. So the requirement is 2 years of work experience in the finance industry, which is pretty vague, but it's the only requirement. The program assumes no previous programming experience, so you don't have to know what Python is or what programming languages are in general. But probably if you're interested in the course, you know that through programming we can achieve a lot of interesting things. The program goes through teaching Python from scratch, so making no assumptions. And it focuses on Python-based tools that are useful for your thinking. So the main approach is trying to make the main approach of the program is pragmatic. So we want to get you up and running as quickly as possible to actually get something useful out of knowing Python. And also the goal of the program is that will enable you to work with financial data sets to gain insights. Like a typical example, you want to get rich and you have some data on stock prices, and then you make some deep insights and you manage to predict the price or something like that. Or it could be in banking, you're looking at the risk portfolio and find some insight. This, for example, this market segment is very risky. We should be more careful, or this is some untapped potential, and so on. So yeah, let's look at the program structure. So first we have a course called Introductory Python Programming, which goes over 4 weeks. Then there's a next course called Intermediate Programming, also over 4 weeks. And then there will be an independent project on Python programming, which doesn't necessarily have to be focused on finance, but is supposed to evaluate your skills in writing Python code and going from an idea to something complete. And then we get more into the fun territory that we actually want to explore. So first we have a course called Data Manipulation and Visualization, also 4 weeks. And then we have the final course, which is called Modeling and Reporting, 4 weeks also. And sort of as a final exam, we have a independent project on financial data analytics, which runs over 2 weeks. And I will talk more about the courses step by step now. So yeah, let's start with introductory Python programming. Here we learn basic programming, like how the syntax works and so on. You will also learn quite a bit about Python standard library, probably more than most people know. This is like the sort of functionality, extra functionality included in the core of Python. For example, basic statistics library, or yeah, basic networking library, things like that. And then we also focus on general programming patterns. So that is very common for people that write code, that their codes, they have this sort of code smell that they know how to program, but they don't know how to program well. So we're going to try to teach you how to program well, because that's the difficult part. Learning syntax is very easy. The difficult part is writing things that don't look horrible. So yeah, that's our focus. And then the next course, intermediate Python programming, starts off where introductory Python programming ended. So now we're looking more into programming paradigms. So first we look at object-oriented programming, which is very popular across other languages such as C++ and Java and those kinds of languages. And we also look at functional programming, which is another paradigm that many people prefer, and it's well, a lot of other languages, maybe not as popular as Java or C++, are functional programming languages such as Haskell or all those Lisps or yeah, a lot of them. But of course, Python is not a strictly object-oriented or functional programming language, but we can do both, and yeah, we look at how we can do either and to solve a given problem. And then we also look at some external libraries now that we're like exhausted the standard library. So in particular, we look at how to make a network request using Python, and using that to do some web scraping, which means like you download a web page and try to extract some information from it. And then we also look at regular expressions, which is a way of defining patterns that match a certain text. If you want to match all the years in a document, you might look for like groups of 4 numbers, which is like a simplification, but yeah, it allows us to define like powerful search patterns to parse our data. And then we have the project on Python programming, which is an independent project on what we have learned in the first 2 courses. It's very open-ended, exactly what you want to do there, but there are some suggestions, but as long as it's has some breadth, and well, that's the only thing we wanted. It has some breadth, and that it showcases that you're able to create something going from an idea to a final project in Python. And then we have data manipulation and visualization. It's the next course. We're going to learn how to clean and manipulate data retrieved from the web and other sources, because these types of data are notoriously dirty, and like there can be a lot of missing values or numbers are treated as strings, and a bunch of problems. So we have to clean up that data, because for the most part, if you want to do data science, most of the job typically consists of cleaning data. So it's not the most fun job in the world, but it's strictly necessary in order to look at the data more closely, to visualize it or more model it, and so on. So it's a very important part. In particular, we're going to leverage NumPy and Pandas for data processing, which are the 2 like most used or basically standard external libraries for Python, and they're used all the time. Pandas was spawned out of a need to handle financial data or tabular data in Python specifically. So it's very tied to financial data analytics. And with visualization, we're going to use matplotlib, which is sort of the de facto standard library to make plots using Python. And we're also going to use Seaborn, which builds upon matplotlib and makes it much easier to make this more complicated and beautiful looking plots. And then also we're going to have a look at something less common, which is interactive visualizations. Of course, they're going to be web-based because everyone loves JavaScript, and but this also gives us a lot of possibility in what we want to do since it is in JavaScript. So we're going to look at the libraries Bokeh, if I pronounce it correctly, Dash and Plotly, which are, even though interactive visualizations is not the biggest thing in the Python ecosystem, these are the most popular libraries there as far as I know. And then the final course is modeling and reporting, how we're going to look at data processing for machine learning. Like, okay, even if you have a clean data, you might want to normalize it, and you might want to do some feature engineering, because like the raw data is not maybe there's a lot of noise, or it's you have some insight that you want to give to your model, so you can compute some new feature and give it, and maybe that leads to getting a better performance. And we're also going to look at statistics and probability theory and their applications in finance. So like computing useful statistics for financial data. So of course you start with the mean and the variance, and then you can look at like the skewness and kurtosis and all this more complicated statistics that might or might not be useful. Definitely some of them at least are useful in gaining understanding of your financial data in general. And yeah, we're also going to look at some hypothesis testing, like seeing if your data is normally distributed or not, for example. And then we also look at computing empirical probabilities that you could use, for example, in hedging and managing risk. Like for example, what's the probability that the closing price of a stock increases 3 days in a row? That is very easy to calculate using pandas and Python. It's much harder to do in Excel. So this is a very useful things we can do with Python. And yeah, then we're also going to look at the more modern machine learning techniques, such as random forests and gradient boosting and all that fun stuff. And of course, we're going to look at deep learning, because everyone is, and it's a very promising field in general. And there are also a lot of, I would say, call them incipient applications to finance, because I mean, yeah, it's been explored, but there's a lot of stuff we can still do, and people are not leveraging much, not far from everything in deep learning, especially with regard to what's going on these days. So that's very exciting, and yeah, probably maybe the most exciting part of the course. Can be promising, and it's almost a little bit research based. And yeah, then we're also going to learn how to write beautiful and efficient financial reports, because that's very important. After all, like when you have gotten your insights and you've made your deep learning model and you've made your beautiful interactive visualizations, you have to put them in a larger document so you can be able to communicate efficiently, and that is a very underrated skill. That if you do have the skill, it does set you apart compared to many other people who know how to program in Python, but you know how to write. And yeah, and like learning how to communicate your findings to non-technical personnel, because that is very it's not easy. It's one of the hardest things in this program, perhaps, but it's very necessary. Even if your boss has no idea what a computer is or what Python is, and things like that, it's important to say that, okay, we found out a way to make more money from this thing, or we found out a way to lose less money from this insight. Like look at different customer segmentations in like in your loan portfolio, and you find some insight that says, okay, these customers are really bad from this sort of segment, and we don't want them, and this is a way to update our model, so the real risk is reflected in our how can I say it, in our like fake risk or our model risk, you know, that our model becomes more prone to being looking like reality, I guess. Yeah, we're gonna spend time focusing on that because that will really help you set your career apart. As long as you know Python and this, those are the two main things I would say. So yeah, and then finally, yeah, we have the project on financial data analytics, which will really be like, I guess, a litmus test for you to see that you understand or know how to work independently with new data and can gain insights. And yeah, the project will run over 2 weeks, and you're expected to go from start with the data, do all the data cleaning, do all the data visualizations, do the machine learning if you want to, all the stuff. And in the end, you're going to write a report, which, okay, can have technical components, but it should also be readable. At least the summary should be, or the first parts of the chapters, let's say, should be readable by non-technical personnel. So if the non-technical personnel or stakeholders read it, they will still understand, like, this is your findings, and not be confused by all the jargon. So yeah, this will be sort of, yeah, like the final exam. And if you manage to do well here, yeah, you know how to do data analysis with Python. Yeah, and you're encouraged to work with real data analytics. So if you real data, so I mean, if you have some data from a previous job or your current job, you're encouraged, as long as you're allowed to, you're encouraged to work with that data. So finally, I'm gonna ask if there are any questions to the presentation. So now I see, okay, who is this program suitable for? So this program is suitable for, the requirement is that you should have at least 2 years experience from the finance industry. And if you do that and you are interested in, let's say you have worked in the finance industry and you know how to use Excel and get some insights from there, but you want to sort of expand on those powers and be a little bit more technical. It doesn't mean becoming a nerd, but it means like doing something slightly more advanced with data. Like, okay, you can formulate a question in your mind, but you cannot solve it using purely Excel. So if you learn Python, you will learn how to do that. And yeah, what are the career opportunities after completing this program? So I'd say this program assumes you already have 2 years experience from the finance industry. So the main goal of this program is to not necessarily change your career path 180 degrees, but rather to empower you to, okay, if you are a risk manager, for example, okay, now you're a risk manager who knows Python and can gain more useful insights and can actually test some modeling techniques and stuff in your work. But even so, I mean, if you do know Python and you already have a background from finance, it's a very broad what you can work as. But like general titles include data scientist and machine learning engineer. In general, almost any job in finance that involve working with data at some point would benefit from this, from knowing Python. And the next question is, how do you incorporate real-world financial data sets and case studies into the learning experience? So I mean, oftentimes when we introduce new concepts, especially in the third and fourth courses, which are specifically focused on financial data analytics, we do so looking at real data. For example, we might look at Apple's stock price from 2023 and learn about probability from doing examples there and actually getting some useful insight into the data. And like, unfortunately, there's not an extreme. It's not extremely easy to find special types of data in finance. Especially banks are very protective about their data, so you're not going to get like any AML data set easily from them, or like get statistics, more detailed statistics of how their risk portfolio or loan portfolio, whatever, looks like. So it's a bit limited in what we can do in those settings, but with focus on what's available, the data that's available, that we use, and then we teach you how to transfer those skills onto the sort of proprietary data that you're no doubt is going to work with in your job or current job or a new job. The next question is, how do you ensure that the program remains adaptable to changes in technology and industry trends? I mean, right now the industry trend is basically AI. That's the most recent one, but for a while it has been that the finance industry has been lagging a little bit behind, and there are a lot of dinosaurs like old banks and stuff that still use very outdated programming languages, and just having Python for them is like getting pure oxygen, you know, because you can do the data analytic tasks that you used to do before in a lot fewer lines of code and using more up-to-date libraries. And I mean, the libraries we're using, like NumPy and Pandas, have some seniority, and I don't see any reason why they should be phased out. Like now, there are some like more modern Python libraries that basically do what NumPy does, like numerical processing, but with focus on GPUs. And those are interesting, but they're very similar to NumPy. I don't think there's going to be any radical change in the Python ecosystem, and I don't think it's going to be any radical change in finance, except with regard to AI. Like there's a lot of data now, and there's going to be even more data in the future. So it's a question about scale, the more a quantitative change than a qualitative one, as far as I see. So the program should be future-proof, because also the focus is on the techniques and not specific syntax of everything, because that's very easy to learn once you know it. Like if you know Python, it's not hard for you to learn C++ because you know the programming concepts already. How is the need for this expertise in the financial industry? Yeah, so like I said, like a lot of banks or financial firms in general are dinosaurs, and also a lot of them want to become dinosaurs, want to stay dinosaurs. They don't want to update with the newest technology and stuff. At least that's been the case. But now there's, like, with all this AI hype and stuff going on, and big data and stuff in general, there is sort of a need to like publish or perish in this setting, that a lot of financial firms are forced to modernize. And like, okay, if you're a bank that has been surviving for 100 years, you still need to modernize and take in new techniques. But that being said, I mean, there are a lot of financial firms that are very on the bleeding edge of numerical processing and AI, and basically get their own edge from being good at AI or efficient data processing, like certain trading firms that do this hyper fast buys and sells of stocks or other instruments. They're very they depend very much on their technology stack being modern and fast and these things. So yeah, the need in the financial industry is, I would say, is quite large, both for existing firms and for the firms that are gradually going to adapt to this, and also, of course, new firms focused on AI and stuff. This is a growing trend in the industry. Yeah, then I think I answered all the questions that I can see. So please let me know. Yeah, and no more questions. So I'm gonna wrap this up. So then I just leave the meeting, I guess. So, yeah, thank you for listening. Bye.